Hey everybody, Mr. Rubo here, and today we're going to talk about recursive rules with sequences. So we've talked about explicit rules, which were like the arithmetic sequence, the geometric sequence. The explicit rules are ones where the n is part of the rule, right? So you can see here like a sub n equals 3n minus 2. That's an explicit rule. Same thing with the other one, the 5 times 2 to the n minus 1. It's explicit because the way we find the term is we substitute in the term number. So I want to find the 100th term, I just put in 100. Those are really nice. However, they're not necessarily always the way we think about sequences, how we think about the patterns. More so, we think about them in more so of a recursive matter, which is basically saying we use the previous term to find the next term. Okay, so there's a way of writing those rules, and you'll see it here. So with these types of things, they will always have to give you like the first term or the first two terms, how many ever you need to find the next term. So here, a1 equals 1. So hey, we want to write the first 5 terms. We've got the first term. So we're 1/5 of the way done. So now in the rule though, it says a sub n equals a sub n minus 1 plus 4. Well, if I, just for sake of seeing it once, if I do a sub 2, because that's what I want to find next, the second term, it would equal a sub 2 minus 1 plus 4. Well, 2 minus 1 is 1, which means I'm really doing the first term plus 4. And that's kind of how we think about the pattern, right? We see like, oh, I'm adding 4 every time, so let me just add 4 to the last term to find the next term. So that's what this is saying. The first term is 1, so it ends up being 1 plus 4, which is 5. So a2 equals 5. Nice thing with this is once you understand that, now you're just really taking the previous term, adding 4 to find the next term. So a3, taking 5, adding 4, getting 9. a sub 4, the fourth term, taking 9, adding 4, getting 13. And the last term that I care about for this problem, I'm taking 13, which is the previous term, plus 4, which gives me 17. Okay? So that's how this is going to work. You can see here with part B, we're told the 0th term, which we'll say is our first term, is 2. So then I want to find a sub 1, which would be 3 times a sub 1 minus 1, which is 0. So a sub 0, which is 2. So I would get 6 for my first term. And then you can see the pattern, oh, I'm multiplying by 3, which is what the rule tells us anyways. So a sub 2 would be 6 times 3, well, 3 times 6, but that's okay. So 18 would be then 18 times 3, so 54, and then do that until you find all 5 terms, okay? Sometimes these recursive rules require you to know the 2 previous terms. So you can see here, they tell us the first term is 1, second term is 2, and then in the rule, this guy would be the last, like the previous term, the most previous term, and then this would be the second to last term, like the previous term of the previous term, if you will. So 2 back, we'll kind of write that. Okay, so this would be 1 back, 1 term back, 2 terms back. So I'm doing a sub 3 because that's my next term. I would do a sub 2 for, sorry, I wrote the wrong thing, would be 1 plus 2 times the first term, which would be 1 as well. So then I get 3. A sub 4 would be previous term, so 3, and then 2 back, which would then be 1. So I would then get 2 times 1 plus 3, which is 5. And then the last term I'm looking for is a sub 5, so previous term. Ooh, computer's going a little wacky there. Let's fix that, not the eraser. There we go. So it would be the previous term plus 2 times 2 back, which would be 3. So there you can get 11. Okay. This type of sequence where you're using 2 previous terms actually gives us one of the most common, or one of the most famous sequences, which is Fibonacci sequence, which is adding the 2 previous terms to find the next one. Something that gives us a lot of interesting patterns that happen. But yeah, that's when there's multiple things. And then sometimes we get rules that are kind of like a combination of explicit and recursive. So you can see here, we're told a sub 1 equals 3, and then we have a sub n equals a sub n minus 1, so the previous term, over the term we are on, like the term number we're on. So a sub 2 would be 3 over 2, because we're on the second term. A sub 3 would be the previous term divided by 3, so we'd simplify that, and we'd get 1/2. A sub 4 would be 1/2 divided by 4, which would be 1/8, and then so on and so forth. Realize I probably was blocking that with my head. So yeah, you would just keep doing that pattern until you got how many terms they wanted. Okay. So yeah, you are using the previous term when it comes to the recursive. Okay, so the last thing is just kind of, we talked about the explicit rules with arithmetic and geometric. So the recursive equations, now these ones I don't give you on the formula sheet, so you will want to know them, but it's what we kind of think of when we do this. So the next term equals the previous term plus the difference, that common difference. For the geometric, it's the previous term times the number that is the common ratio. So here we could see we are adding 10 every time. So my recursive rule is a sub n equals the previous term, so a sub n minus 1 plus 10. And that's it, right? And that's the way we kind of think about sequences anyways. We're thinking, oh, we're adding 10 to the last term, to the previous term, to find the next term. This one, when we look at it, we end up doing some multiplication, and if we think about it, if we're not sure, we can just kind of do 40 divided by 16. So what? We'd get divided by 4, 10/4, which we could have divided by 8, would be 5/2. So we're multiplying by 5/2 every time. So I'm going to say a sub n equals the previous term times 5/2, and there's our rule. Okay. So recursive, when you're writing an arithmetic or geometric sequence, it's kind of how you would expect, how you think about that sequence. You're adding 4 every time. You're adding 4 to the previous term is what it really is. Geometric, you're multiplying every time, so you're multiplying by the previous term every time. Okay. So yeah, that's all I've got for you today. So thanks for watching, and have a good day.